Okay. So in last class, we have started this beam design, right? So, so in settings, we have done half of the thing in general and reinforcement setting. Okay. So I'm not saved, I think. So up to this crack width check we have done. Sorry, up to this nominal percentage of steel we have done. So remaining things we have to discuss today. So I'll correct these values now. Okay. So next one is crack width check. Right. So here in RCDC it will consider the crack width also and it will design. Okay. But whereas in ETABS if you take, it would have not designed for crack width, only for the strength and deflection check it would have done. But crack width it would have not checked in ETABS. But in RCDC have this crack width check. Okay. And also here for the beam, there is only one crack width check. So generally there are two types of cracks, right? One is the thermal and the other one is shrinkage crack. But for the slab which we have done earlier in RCDC, so there we would have checked this perform check we would have given for both thermal as well as the shrinkage crack. So here it is asking only the shrinkage crack, right? So since slab is a very big element, right? It's an element, so it's a very big element. So because of that, it will be subjected to thermal crack, right? But if you take a beam, it's just the member. Okay, when you compare the size of the beam and slab, it's very small. It's just the member, right? So it will not undergo much thermal crack. So it will undergo only the shrinkage crack. So that's why here it's enough to check the shrinkage crack, right? That is the most predominant, right? So check this perform check, and permissible limit is 0.3 for normal conditions, right? 0.3 and design code IS code 5. So this IRS is for roads. So in roads we don't. So in design code is IS code 5. And next one is material properties. Material properties M25 FE415. So this is taken from the analysis from the ETABS. So if you want to change also, you can change to some other grade. So here use material properties from analysis. If you tick this, it will be taken from analysis. Okay, whatever it is given in ETABS, it will take from that. Otherwise, if you want to change this, you can untick this and you can change to whatever grade you want. Okay. So here, steel grade only becomes inactive when you check this, use material properties from analysis. Sorry, this concrete grade, but steel grade is still allowed to be changed. Okay. So next is clear cover. Cover for beam 20 mm and maximum aggregate size. So this aggregate size, it should not be greater than cover. Okay. It should be equal to cover or less than cover only. It should not be greater than cover. So keep it 20 mm. The next one is, this is rebar settings. So same as slab only. So this is available rebar. So whatever the rebar which is available in your site or in a warehouse, so you can tick those rebars. Okay. And next one is main steel rebar. This is asking for the minimum diameter of the bar to be used and what is the maximum diameter to be used. Okay. So this value you can just give randomly, but it is not going to take the exact diameter. So it will, if you give minimum here 12 mm, so this is main bar. Okay, so minimum 12 and maximum, let us keep 25. So if you are giving 12 with the minimum, maximum 25. So it will try for that 12, 25. If it is not no fitting, so if it fails, it will go with the next size out of this available thing. Okay, so it will not strictly follow whatever you give here. This is just the preference. but it will change accordingly according to the design. Okay. And shear bar for the shear rebar for the stirrups. Minimum we can keep 6, okay, 6 mm diameter. Next maximum we can keep 12. Okay. So since this is beam, we can minimum we can keep 6 mm. If it is column, we have to provide minimum 8 mm. Right? Next, this is side face reinforcement. So I'll explain what is side face reinforcement. SFR means your side face reinforcement. So this is beam cross section, and this is we have main bar here. With stirrups. Okay. So generally, while pouring the concrete, after putting the reinforcement, while pouring concrete, so sometimes this reinforcement, right, it may bend. Sometimes it may bend like this. Sometimes it will not happen every time. Generally, it won't happen, but sometimes it may happen. It will bend like this, okay, while pouring the concrete. So to make it stiff, so this is like sagging. It will sag, okay. So to make it straight, okay, to hold this, to prevent it from sagging, we provide the reinforcement here. We provide the reinforcement here. So this is nothing but the side face reinforcement. Okay. So this sagging will generally happen if beam depth is more. If depth is greater than 300 mm, this sagging may happen. So due to which they provide the reinforcement here. So which is the side face reinforcement. Okay. So the side face reinforcement, we can provide minimum reinforcement, right? Based on your breadth and depth of the beam, we can provide minimum reinforcement. So that is enough for side face reinforcement. Okay, so it's asking the minimum and maximum diameter for side face reinforcement. So we can keep same as the stirrups, 6 and 12 mm. And next one is stirrup spacing. Stirrup spacing, or minimum spacing, you can give any comfortable spacing. So let us keep 300 mm minimum spacing, and maximum spacing according to your wall thickness, not more than your wall thickness, can be less or equal to wall thickness. So we can keep 230 mm, and spacing round off can be 5 mm. And next one is different rebar for outer and inner stirrups. So that means, so generally according to the Indian code, so we provide a stirrups like this, right? Say for example, this stirrups is one stirrups, okay, only one stirrups with, say for example, 12 mm diameter. Okay, this is the stirrups. But in some codes, they provide like this. This one 12 mm diameter stirrups, they split into two. For example, they provide like this. So this is our main bar. So they split into two like this. One they provide outer, and they provide inner like this. So this is one 6 mm diameter. Okay, they provide actually like this. Okay. So like outer and inner. So this is 1 6 mm diameter. This is another 6 mm diameter. Like this, they provide in some codes, but we generally don't use like this outer and inner concept. We provide one stirrups like this outer. So if you want outer and inner kind of stirrups, you can check this. Otherwise, we don't generally use this. You need not tick this. So now here we have completed this general and reinforcement settings, and you can click OK. Okay, so minimum. Okay, so minimum is 6, but I have not selected the rebar in this available rebar. So I need to check this. Okay, I need to select the 6. So if it is not available, how it can provide, right? So we need to check this, we need to tick this available one, and then select this and click OK and save it. So next we can go to next settings, rebar curtailment. So this is curtailment setting. So curtailment means so this is the beam. To take the elevation in beam design, we would have provided the bars like this. Okay. So this may be three number of bars of 25 mm diameter. It will be running throughout like this. And here few bars, say for example 225 mm diameter, may be extended only up to this tension zone, right? So up to this some distance. Okay, that distance is based on your support, whether it is end support or whether it is continuous. So based on that end condition, this distance will vary, right? That bending moment will vary. So accordingly, this distance will vary. So here, if it is end support, it is L by 4. If it is continuous, L by 4. Midspan, if it is this is at the midspan, it will be L by 6. So these curtailment location, it will be by default taken from the code. Okay, you need not enter here anything. So this will be automatically taken from the code. Okay. So next is shear zone. Shear zone for ductile beam. It's asking the factor of depth. If it is ductile beam, you can check this here. You can enter the value here. If it is non-ductile beam, you can enter the value here. Okay. So this shear zone is like for the spacing of stirrups. It's asking the factor of depth. Uh, factor of depth. So for example, for ductile beam, in as per ductile design code book is IS 13920, right? So this is the ductile code book. So during the seismic design, we would have discussed, right? So, okay. So if it is SMRF, okay, if it is ductile, then we need to give the spacing of the stirrups according to the stress zones, right? So the stirrup spacing, it will not be uniform. So here it may be more stirrups. This is I'm marking in high stress zone. If this is high stress zone, here there will be more stirrups with less spacing. And this is high stress zone. This is low stress zone, and again here high stress zone. Okay. So here less stirrups with more spacing. And in high stress zone, it will be more stirrups here. Okay. So this what is the distance of this high stress zone? So if you refer to IS 13920, this distance will be 2D. So this is the factor it is asking, factor of D. So factor of D is 2 for ductile beam. Okay. So but here we are not going to do ductile beam here. It's non-ductile beam only. So for that factor of depth, but for non-ductile beam, we don't provide this kind of spacing. This is it is not equally spaced, right? But for a ductile beam, we provide equally spaced one. So throughout the same spacing only, right? So, but still it is asking for the factor. There is no such factor for this. Okay. So here you cannot give 1 also. So if you give 1, it will object. So value should be between 2 and 5. So we can give 2. Okay. So anyway, this is not valid one because the spacing is going to be the same for non-ductile. Okay, anyway, you can give the minimum one because it won't accept it. So I'll give 2 and click OK. Okay. So next we'll move on to the next setting. Detailing and drawing setting. So in this, it is asking for the detailing setting. This is just the detailing setting and rebar anchorage. So anchorage means is development length. Okay. So cantilever tie back bracket anchorage. What is the factor? What is the development length into factor? So development length into factor is I think in last class we have discussed. So development length into one-time factor for OMRF. Yes, here we have discussed it, right? So OMRF means one-time factor, SMRF means 1.2 factor, right? So that is what it's asking here. But there are 2 types of anchorage, basically cantilever and bracket. So what is this? I'll explain that. So generally in anchorage, so anchorage is nothing but the development length. So in this anchorage, there are 2 types of anchorages. So one is cantilever anchorage, the other one is bracket. Okay. So cantilever anchorage means, for example, if your beam is continuous beam. So a column connected with beam. So these are continuous beams, right? So if your beams are continuous, so this is reinforcement of this beam, and this is reinforcement of this beam. The 2 reinforcement, longitudinal reinforcement, and this is stirrups. Okay. So generally, the development length for a continuous beam from the face, it will be extended for the development length. So it will be extended straight if it is continuous beam. Okay. So we don't extend it like this. Okay. So we extend it straight if it is continuous. Similarly, this beam reinforcement, similarly this beam reinforcement, it will be extended to this beam. Okay. So this is how we provide. So this is called as the cantilever anchorage. Okay. So why it is called as cantilever? So from this phase, only we provide the development link. So from this phase, it is straight. It is like cantilever, right? So that's why it's called cantilever. And bracket type means if it is end beam. So this is for if it is continuous beam. Next, if it is end beam. So development length from this phase, it will be provided like this in bracket form, right? So this is called the bracket anchorage. Okay, so we have to give the factor for this. For both, if it is OMRF, it's 1. Right? So if it is OMRF, factor is 1. If it is SMRF, factor is 1.2. So give 1 here. Next one is minimum vertical for L bend. So how much should be the distance for L bend? So it is asking this distance. So from this is L bend. Right? So this is minimum vertical length. So it is asking this distance. So that we can give 150. Okay, minimum you can give anything. Next one is secondary beam end anchorage. So secondary, it is asking for the development length for secondary beams. Right? So there are 3 options. Whether you want to provide the development length or any fixed value. Okay, this much value you want to bend it inside. So that fixed value you can give. Otherwise overlap bottom rebar up to the overlap distance. So that distance, up to that distance, if you want to provide the development length, that also you can provide. So mostly click this development length. Okay. So for secondary beam, anyway, there won't be any space. Okay, to provide the full development length, but still you can keep it in development length. Okay. So how much is this space? For that much, it will be bent inside. Okay. So better to keep in development length itself. So for example, suppose for that beam, the development length is as per 50 times diameter, if it is 500 mm, but the space available is just 300 mm, so it will be provided up to 300 mm. Okay, so we can keep it in development length itself. So next one is style. Style means how it should be shown in the drawing, right? So for anchorage length and lap mark. So whether you want to show any anchorage length or not, if you don't want to show any anchorage length and lap, then you can click none. But we don't click none generally. There are two options: actual and fixed text. Actual means if you want to show the distance of the development length, okay, then you can keep it in actual. So it will show the value of the development length. And next one is fixed text. Fixed text means it will just show the development length. For example, you can edit here also according to your wish. So here I can give development length, LD. So this text alone it will be shown, not the value, how much is the development length, that value won't be shown, but it will be showing LD everywhere. Wherever that is development length, it will show LD, right? So you can give this or this, but better keep it in actual. Okay, without the value, if it shows LD, that's no use, right? We must know how much is the development length provided. So that we have to know. So better we can keep it in actual. So same for lap also. Actual means it will show the lap distance how much, and if you just fix a text, it will show like lap. You can give any text here according to your understanding. So better we can keep it in actual so that we will be knowing the value. Right? Next one is rebar couplers. So couplers we mostly don't use. Majority we use lap mark. So this is like either option. So if you take this lap mark, if you take this couplers, then this lap mark is like invalid. Either one we can use, right? So we generally provide lap, so we can uncheck this. If you are using couplers, you can give, otherwise lap. So next one is options. So this option is so whatever the things you want to display, that options here. If you want to mark the unique sections, you can take show spacer rebar. So that is spacer rebars means side face reinforcement. If you want to show that, you can show. So these options you can tick this. So it will show. It will be displayed all these things. So you can tick this. Okay, this is just what are the things you want to show that it is asking you. So next is cut element round-off. You can keep it 5 mm round-off value. Next one is effective span for cut element. So effective span for the cut element, whether you want clear span or center to center. So clear span means from here to here. So this cut element, right? So this is clear span. And center to center means from here to here. This is center to center. Okay. So this effective span for the cut element, we can keep it in clear span. Okay, so that we can match with the cut element distance, whether L by 4 or L by 6, right? We can match with it. So better we can keep it clear span for both top and bottom rebars. Then provide curtailment. Provide curtailment. This is to show the curtailment. Okay. So this option is to just show the curtailment. Whether you want to show the curtailment from support face or from support center, both are same. Like previous one. Whether you want to show from the curtailment from here or from center. So you can give from support face. Next, mark curtailment. From where you want to mark the curtailment distance, from support face or from support center. So that also we can mark the curtailment from support face. Next, mark span also, span of this beam. So marking the span of this beam from support face or support center. So you can mark anything, but support face we can use it. We can match with the architectural drawing. Okay, how much is this span? We can match with the architectural drawing. You can keep in support face and dimensions. So if you want to mark the beam span dimension and support dimensions, you can just tick this. So the dimensions will be shown for the beam span and support dimensions also. And next one is rebar mark manager. So here same way how you want to display the rebar, right? The headings or tags for the rebar. So that you can modify here. However you want, you can modify here. So 25, this is numbers, 25 numbers of main bar of 10 mm diameter. So instead of T, I can keep it main bar. So 25 numbers. You can even put numbers here. Sorry, in the suffix, 25 numbers. Numbers, 10, main bar, 10 mm also you can do, 10 mm diameter, likewise also you can type. But as much as possible, keep it short, okay, so that it will not clash with the other text. So these things I'll remove. 25 is number, it's understood. So I'll take these numbers also. 25 number, main bar, 10 is always the unit is in mm only, that's also understood. So next one is always you can keep in dia. So if you want to mention this dia, you can keep in 10 dia. So next is shear. Shear 25, this is 4-legged stirrups, 10 mm diameter at 120 mm center to center. Okay, so you can edit here. Instead of T, you can keep it shear. Shear reinforcement. So you can keep the ST 10 mm at 120 mm center to center. If you want anything, you can add prefix suffix. Next is shear force reinforcement. So this is 25 numbers, shear force reinforcement, 10 mm diameter. EF means each face. Okay, each face 10 mm diameter and 25 numbers is given here. So this instead of T, you can keep it shear face reinforcement and 10 mm each face. And click OK. And OK here also and save this. Next setting is preferred bar spacing. So here it is asking for this beam width. Okay. So beam width. So among this beam 1 to beam 25. So the beam width is 233 and 230 everywhere is 230, and this beam width is 300. Okay, you have only these two width. One is 230, the other one is 300. Okay, for this beam width 230 and 300, how many number of bars you want to place in this 230 width? So that is what it is asking. So if you remember in E tabs, while defining the column and beams, okay. So in columns, it would have asked for number of bars in 3-direction phase, number of bars in 2-direction phase. Okay. So in column definition, so it would have asked for number of bars in 3-direction phase and number of bars in 2-direction phase. right? For only for column it will ask, not for the beams. In E tabs, we don't provide any reinforcement details for beam in E tabs, right? Even if you provide, it won't take. So we don't provide that. So but for the columns, we will be providing how much number of bars. Okay, the reinforcement details also we provide. So in that, it would have asked the number of bars in 3-direction and 2-direction. So we would have assigned, given this value according to the size, according to breadth and depth in 230 by 300. How much can we accommodate? So according to that, we would have given this value, right? So similarly, in RCDC, it is asking for beam also here. So in 230 wide, how many bars you want? If the rebar diameter, if it is less than 16, how many bars you want? And if rebar is greater than 20, how many bars you want? So that's what it is asking here. Okay. So this is purely for in width only, not for the depth. Okay, so if you provide the number of bars in width side, automatically for depth wise, it will be automatically adjusted. How much spacing you provide here, according to that, depth will be adjusted. Okay. So we'll calculate how much we can provide here. So in this 230, so we need to calculate it like this. So in this 230 wide, so if you are providing 4 number of bars, for example, and each 16 mm diameter, it cover 20 mm. So in this 230 minus cover, okay, so in this 190, if you provide 4 bars, so if you minus 4 times 16, so it is 126. So 3 spacing, you should divide it by 3. It's 42. Okay, so you can provide 4 number of bars. So the spacing, it should not be less than 25. So you can provide 4. So spacing is 42, right? Same way only it is RCDC also calculating, so 42 spacing. So you can even further reduce. So here you need not calculate in this way you need not calculate. So if you, the spacing will be automatically calculated here. So if you just enter the value, supposing I'm entering 5, so this spacing will be automatically changed, right? So if I enter 6 here, this will object. So the spacing should not be less than 25, right? So it is objecting here. So if you enter and see how much is the maximum limit, so that much you can enter here. Okay, so you need not calculate it here. So I'll enter 5. So 5 is the maximum. More than that, I cannot provide. It will show some error here. Right? So in 300, I can provide 6 mm. Let me try. So it's 33. If I provide 7, so it's subjecting. So it will become less than 25. So I'll provide 6. Okay. And for rebar number, which is greater than equal to 20. So here, if I provide 4 number of bar, spacing is 37. I can even provide 5. So 5 I cannot provide. Okay. So 4 is the maximum. Next here also, if I provide 5 here, it's 40. I think 6 will not come. Okay, 6 is accepting. So 7 we cannot do. Okay. So this rebar numbers you can give here. You can give the maximum numbers here. Okay. Next one is provide 2 rebars in zone with 0 bending moment. So that means so this is the beam. If it is singly reinforced beam, so this is tension zone. So the bending moment diagram will be like this. We provide reinforcement according to the bending moment. So this is tension zone, and these are all compression zone. Right? So it is saying to provide 2 rebars in zone with 0 bending moment. So that means this is 0 bending moment zone, right? Which is compression zone. So this is 0 bending moment zone, correct? So these are all 0 bending moment zone. So in 0 bending moment zone, we must provide 2 rebars. Only then it can tie these stirrups, right? So that is the option. If you want to provide 2 stirrups, you have to check this option. So that means in RCDC, it will design as a singly reinforced beam. Okay, it will also design a singly reinforced beam. So if first it will try for singly reinforced beam. If it fails, then it will design as doubly reinforced beam. So in RCDC, this option is there to design a singly reinforced beam also. But in ETAPS, invariably by default, it will design as doubly reinforced beam only. So you have to check this, provide 2 bars in 0 bending moment zone. And click OK and save it. So next is basic load cases. So in basic load cases, for these load cases, we have to select the load type here according to this load cases. So this crane impact load is live load. So you have to select live, and equipment dead load as dead load, floor finish dead load, dead load. General live load is live load. Masonry wall dead load is dead load. Plastering dead load is dead load. And services dead load is dead load. And seismic plus X is earthquake X. Okay, so seismic plus X is earthquake X. Seismic plus Y is earthquake Z. Okay, so in RCDC, this global axis it changes. Okay, so in ETAPS, so global axis. So in ETAPS, this global axis is So this is X, this is Y, and this is Z. Okay, this is the ETABS notation of global axis. But in RCDC, this will change, right? Because RCDC is the product of StatPro, right? In StatPro, this is the global axis. So X and X will remain same. This Y and Z will change, okay? When you compare with ETABS and RCDC, this is Y and this is Z. So vertical axis is Y in RCDC, okay? In ETABS, the vertical axis is Z. So these two will be reversed. Okay, so these two will be reversed. Okay, so StatPro this RCDC follows the StatPro. Okay, so in StatPro, this is the global axis. In ETABS, it's a different product. So this is the global axis for ETABS. So accordingly, we need to give. So if it is seismic Y, that means in ETABS it is Y means in RCDC it is Z. Okay. So in ETABS it is Y means it is the name alone it changes, same direction, but here in ETABS it is Y means same direction, in RCDC it's Z. Only the name changes. Okay, the direction remains the same. Okay, so seismic X, earthquake X, seismic Y is earthquake Z. Next, structural dead load is dead load. Wind load also same way. Wind load plus X in ETABS, in RCDC wind load X. Wind load plus Y is wind Z. Okay. So after entering this load type, select everything and bring this side. Okay. Next we have to go with the load combinations. So we'll stop here. So it is immediately asking for load combinations. Okay, so later we'll do the load combinations in next class. So stop here, it's already time. So any doubts, sir?
This RCA class is there, madam, today?
RSA class, sir.
RFA or RCA, some class is there, no?
Response spectrum class, sir.
Ah,
I don't know, sir. You need to check with the sir. He told he is
okay.
still sick today. So maybe I don't think so. Better contact sir.
Okay, madam. Okay, thank you. Thank you.
Thank you. Thank you all. Sir.